Hello everyone, welcome to the course on stereochemistry. In this course, we will learn the various aspects of stereochemistry, like starting from chirality, stereochemical role of some chemical reactions and rearrangement reactions. The methods of assigning the configuration will also be taught. This course is well suited for the students to get in-depth knowledge on the stereochemistry. I am sure that the students will not find it difficult to understand the concept, as suitable examples are shown for the demonstration of each concept. So let us begin the session. So in the first week, we will learn about isomers and their classification. The word isomerism is originated from Greek word isomer. Iso means same, mers means parts. When two or more organic compounds having similar molecular formula but exhibit differences in their chemical or physical properties are called as isomers, and the phenomenon is known as isomerism. Generally, isomers can be divided into two types. One is structural isomerism, also called as constitutional isomerism, and another one is stereoisomerism. So constitutional isomers, also known as structural isomers, they are having same molecular formula but the differences in structure, in which it's due to the differences in the arrangement of atoms within the molecule, irrespective of their position in space. In other words, structural isomers are the compounds those have identical molecular formula but different structural formula, and this phenomenon is known as structural isomerism. However, stereochemistry of the organic compound can be defined as the chemistry of that compound in space and as a function of its molecular geometry. Structural isomerisms can be subdivided into 5 types. They are chain isomerism, position isomerism, functional isomerism, metamerism, and tautomerism. Similarly, the stereoisomerism can be subdivided into configurational isomerism and conformational isomerism. So, stereoisomers are the isomers which will have same molecular formula but they will have different arrangement of atoms in space. So they are classified into two types, conformational isomerism and configurational isomerism. So let us see about them in detail later. First we will concentrate on structural isomerism. So in structural isomerism, the first one is chain isomerism. Chain isomers are those compounds having difference in order in which the carbon atoms are bonded to each other. So in other words, chain isomers have variable amounts of branching with the hydrocarbon chain. That is, if you have two or more molecules having same molecular formula but they differ in their hydrocarbon chain length, then you should recognize them as chain isomers. For example, let us consider the molecule with molecular formula C4H10. If you see the structure of those compounds, that is N-butane and 2-methylbutane, that is isobutane. Here, these two compounds have different chain length. Although they have same molecular formula, but they have different chain length. So as the number of carbon in the chain length differs, these compounds are called as chain isomers. Similarly, if you take C5H12, the compounds 2-methylbutane and 2,2-dimethylpropane are chain isomers. So the molecules with same molecular formula but different in the structure, that is difference in carbon chain length, that are said to be chain isomers, and the phenomenon is known as chain isomerism. So next one is position isomerism. So let us take two or more molecules with the same molecular formula but having difference in the position of the functional group on the carbon chain are called as position isomerism. So if you observe the molecules with same molecular formula but differences in the position of the functional group are known as position isomers. See, for example, here in C3H8O, that is 1 propanol and 2 propanol. Both are having same molecular formula, same functional group, but the position of the functional group, that is OH group, is the only difference here. So these two are called as position isomers. Similarly, C4H9Br, it is 1 bromobutane and 2 bromobutane. Here bromo, that is the functional group. So the position of that functional group is different in both the cases. Hence these two compounds are called as position isomers. So the position of functional group is the only difference. So then it is called as position isomer, and the whole phenomenon is known as position isomerism. Next one is functional isomerism. Two or more than two molecules having the same molecular formula but different functional group, then they are called as functional isomers. So if you observe two or more than two molecules having same molecular formula but having different functional groups are called as functional isomers. So let us take an example. C2H6O, that is ethanol and dimethyl ether. These two compounds are having same molecular formula but they have different functional group. So one is having alcohol functional group and another one is ether functional group. So these two are functional isomers. Similarly, functional isomers of C3H6O are propanol and propanone. So one is aldehydic functional group, another one is ketone functional group. C3H6O2, propionic acid and methyl ethanoate. So these two are functional isomers. So the definition is, the compounds with same molecular formula but different functional group are called as functional isomers. This phenomenon is known as functional isomerism. So let us move on to the next classification of structure isomers, that is metamerism. Two or more than two molecules having same molecular formula and same functional group but having difference in the distribution of carbon atom on either side of the functional group are called as metamers. This phenomenon is known as metamerism. So when you see two or more than two molecules with identical formula and identical functional group but they have two different structural representation, that is the distribution of carbon chain length on either side of the functional group, if that differs, they are called as metamers. See, for example, diethyl ether and methyl propyl ether. These two are having same molecular formula and having same functional group, but if you see the carbon chain length on either side of the functional group, so in diethyl ether case we have two ethyl group on either side, and methyl propyl ether has one side we have methyl group and another side we have propyl group. So these two are metamers. Similarly, C4H11N, the compounds diethylamine and methylpropylamine are metamers. Okay, let's move on to the next concept, that is one of the classification of structural isomerism, that is tautomerism. Compounds having same molecular formula, those are interconvertible, and also the existence of dynamic equilibrium between the molecules are called as tautomers, and the phenomenon is known as tautomerism. See here, ketone and enol both are interconvertible by simple migration of proton, and there exists the dynamic equilibrium between these two molecules. Hence, ketone and enol are tautomers. So this is known as keto-enol tautomerism. Similarly, we also have nitroacetautomerism, and amido-amidol tautomerism, and so on. So these are all structural isomers. So the next classification of isomerism, that is stereoisomerism. This is a very important type of isomerism. So this can be classified as conformational and configurational isomerism. Configurational isomers are classified as optical and geometrical isomerism. So we are going to learn about them in detail in the whole course. So let me just give an idea about what is conformational isomer and what is configurational stereoisomer. So conformational stereoisomer, they are interconvertible with the minimum amount of energy. So that is, for interconversion they need very less amount of energy that can be obtained at room temperature itself. Since the energy required for interconversion is less, so this will be happening very quickly. So these cannot be separated out. These are called as conformers or flexible molecules, sometimes also called as rotamers. So next one is configurational isomerism. So they are non-interconvertible. So high amount of energy is required for interconversion. So that is not available that easily at room temperature. These isomers can be separated out. So they are actually rigid molecules. So we are going to learn about them in detail in the upcoming classes. So right now I conclude this session. We will meet again in the next session. Thank you all for listening.